We're setting up to do a strength test on the 3 screws that secure the valve into the Beeman Chief PCP. I've got a simulation of the tube. This is 26 millimeter OD and 22 millimeter ID. 3 holes here for the screws. The screws are a nominal 4 millimeter diameter. By 5 millimeters long. Got 3 of them. I've got a plug here with the 3 holes drilled in it and tapped. It's going to fit down in here. It'll go in a lot farther, but the screws will retain it out here. And then we're going to take and do a test on it, put some force on it, and see if we can break the screws. We've got the plug installed here in the simulated tube, simulated valve and tube. We've got the 3 screws 90 degrees apart. Plug sticks out. I'm switching to inches here. About 212 thousandths out of the end of the tube, so we'll know how far it gets pushed down inside there. Here's our test setup to test this to see where we break the screws at. We've got a hydraulic bottle jack. It's a 6-ton jack. And up on the top, we've got a piston set up here. Piston in here that has 1 square inch of area pushing up into this cylinder. We've got a 6,000 psi gauge on it. Now, because we've got 1 square inch of area on this, on the piston, this will read directly in pounds of force. So if it reads 3,000 psi, it's also measuring 3,000 pounds of force on the bottom of this, on the bottom of the piston. So it's a 1-to-1 relationship here. Okay, we're set up and just about ready to start the test. Our test piece is in the middle. We're going to go ahead and pump it up a little bit to take up the slack, get some pressure, and we'll take some measurements, and then we'll continue from there. Alright, it's just starting to make contact now. I'm going to pump it up. And go up to about 1,000 psi. That'll let the screws seat. 1,000 pounds of force, 1,000 psi. Alright, a little bit over 1,000. Let me go ahead and measure up here again. Okay, when I just put the screws in, reading about 210. Now we're reading about 195, and that's just taking up the slop in the holes. Alright, so we're at 195. Alright, now we're going to continue on up. And we're over at 2,000 pounds. Here we are at 3,000. That little backward movement is the check valve within the pump. All right, let's go ahead and take a measurement here. Okay, now we're at about 160. Now, it's hard to say if anything is yielded, but something probably has. So we're going to continue. All right, now I can tell right now I'm pumping but the pressure isn't increasing. That means that we're getting movement up in there, that things are starting to happen. All right. Okay, now it's getting ready to go right now. Let me take a measurement again. All right, now we're at about 0.126. And we really started about 195, so that's 70 thousandths. That's a good 1/16 of an inch movement inside here. Something has happened. Screws have bent, had shifted in the aluminum or whatever. But it's not a catastrophic failure yet. Even though it has failed, it's not like this has popped down inside there, or the screw heads have popped off. All right, so let's continue. And there we went. Continue. And there, and I missed what the actual force was at. Okay, but all three of the heads popped off. It was a little over 3,000. So let me get a couple close-up pictures here. Take this off the tripod. All right, here we are after the test. You can see the pressure hasn't dropped all the way to 0 because the tube, because the part shifted, but it's still loaded. All right, let's see here. You can see here the broken screw in there. Another one in there. This gap in here started about 0.195 and now it's about 0.085. So we've moved a good 1/8 of an inch there, and you can really see that in here. You can see how far it's moved. Here the screw heads are. I recovered 2 of them. The other one's somewhere else. I'm not quite sure where. But I don't know if you can see, but you can see where the head of the screw broke down there at the base of the Phillips. You can see a hole through it and popped right off. So that's what we've got.